Hello, my name is Goswami, and today we are about to start our next domain, physics, and we will start it from the scratch. Let's first talk what is science and what is the scientific methods. So first let us talk about what is science and what are the so-called scientific methods. So first let us take some naturally occurring phenomena. Let's say for example volcanic eruption, cyclone, maybe eclipses or some astronomical events like supernova explosion, or maybe studying the nebula or something like that. If you make a detailed study about these naturally occurring phenomena as detailed as possible and use the knowledge you gain to predict or to modify or to control the phenomena, but that is known as science. So science is exploring, experimenting, predicting what we see around us. So now let's move towards the scientific methods. What are they? Now the scientific methods include several steps. We start with systematic observations first. We see each and every detail of the system, of the phenomena, and after that we do some control experiment on those phenomena. After that we do some qualitative and quantitative reasoning, and then we do a mathematical modeling. Okay, now let me explain this one. Let us take for example the cyclone. Okay, so at first a cyclone occurred nearby. At first the scientists would study the cyclone, how it originated, in which way it's going, each and every detail they can study. After that they try to do some experiment or some qualitative or quantitative reasoning about the cyclone, and then they make a mathematical modeling. Now what is mathematical modeling? They use mathematics to figure out in which way that cyclone may move, whether that cyclone will affect us or not in future. So those things are mathematical modeling. Mathematics is key in science, okay, for this reason especially. After that we need to verify this. So it is verified by some relevant observations and some different experiments which will prove what you just said as your theory. Now let's come to what is physics. Okay, physics is a branch of natural sciences, so as biology and chemistry. So we can broadly describe physics as the study of basic laws of nature and their manifestation in different natural phenomena. In physics we attempt to explain the diverse physical phenomena in the terms of a few concepts and laws. Let's say for example the same law of gravity that describes the falling of an apple from a tree, that same law is used to describe how moon is moving around the earth and how earth is moving around the sun. In fact, how all the planets are moving around the sun. So these sort of things, all of these are explained by using the law of gravity. Now the basic law of electromagnetism governs the electric and the magnetic phenomena, all of them. Now let us talk about the scope of physics. Basically there are two domains of physics: the macroscopic domain and the microscopic domain. The macroscopic domain includes the phenomena at the laboratory scale, maybe terrestrial or astronomical. And the microscopic domain includes atomic, molecular and nuclear phenomena. The classical physics mainly deals with the macroscopic domain, which includes the subjects like mechanics, electrodynamics, optics, maybe thermodynamics. So mechanics was founded on the Newton's law of motion, and the law of gravitation is concerned with the motion of the particles, maybe rigid bodies and deformation of bodies, and general system of the particles. Okay. Mechanics also includes the propulsion of rocket by a jet, that's by ejecting gases. Now let's say about electrodynamics. Electrodynamics deals with the electric and the magnetic phenomena associated with the charged and the magnetic bodies. Optics deals with the phenomena involving light, the working of telescope, microscope, color exhibited by thin films, all those things. This falls under the branch of optics. Now let's come to thermodynamics. Thermodynamics deals with the system in macroscopic equilibrium and is concerned with the changes in the internal energy, temperature, entropy, etc. of a system through maybe external work or heat transfer and all those things. All these things will be taught in detail in later chapters. This is just the introduction of each and everything. Thermodynamics also work with the efficiency of heat engine, refrigerators, and all those problems. Now let's see the microscopic domain. The microscopic domain of physics deals with the constitution and structure of matter. Now microscopic domain deals with the scale of atoms and nuclei, the smaller scales, and the interaction with other electrons, protons, and other elementary particles. Classical physics is not adequate to handle the microscopic domain of physics, so the quantum theory is now currently accepted as the proper framework for explaining the microscopic domain. So hence we can say that the scope of physics is vast. Okay, it covers a tremendous range of magnitude of physical quantities like length, mass, time, energy, etc. For example, let us say in case of length, for electron it involves a small scale of length, which is of the order of 10 to the power minus 14 meter or even less. But if we talk about astronomical length units, the extent of our current universe is approximately about 10 to the power 26 meters. So it's a huge gap. In fact, the gap between these two orders is about 10 to the power 40 or even more. The range of time can be found by dividing the length scale with the speed of light, and it comes out to be 10 to the power minus 22 seconds to 10 to the power 18 seconds. That's a huge gap. Now let's see the range of mass. The range of mass goes from say 10 to the power 30 kg, 10 to the power minus 27 kg or 30 kg, approximately in that range, or to 10 to the power 55 kg. Now that's the mass of the observable universe. Every terrestrial phenomenon lies somewhere in the between of this range. Now let us know something about the fundamental forces of nature. Okay, so we all have an intuitive notion of forces. In the macroscopic world, we encounter several kinds of forces, like the muscular force or contact force between the body, friction, the force that is used to compress or elongate springs. So for all these things we need a force, and this is something we know about. But all these forces are called derived force. These forces are not the natural forces or the fundamental forces. These all forces are derived from some other fundamental forces. That could be explained with an example, like the force that we need to elongate a spring. That could be explained by the electromagnetic force between the atoms of that spring. The atoms are being pushed and pulled by the force. So all these forces can be summed up by some fundamental force in nature. So what are these fundamental forces? Let's see what are the fundamental forces now. And the first fundamental force is the gravitational force. Okay, the gravitational force is the force of mutual attraction between two objects by virtue of their nature. So the gravitational force is always attractive, and it is a universal force. Every object in the universe experiences the gravitational force due to each and every other objects in the universe. For example, we are experiencing the gravitational force by the earth. So whenever we jump from some place or even we throw anything up to the sky, it comes back to the earth. That is gravitational force. Gravitational force also defines the motion of moon around the earth or the motion of planets around the sun. All these things are defined by the gravitational force. Now let us see what is the electromagnetic force. Electromagnetic force is between the charged particles. By charged particles, we would say the particles like electrons, protons, those type of things. Now electrons we know are the particles that are negatively charged, and protons are the particles that are positively charged. Now there is a difference between the electromagnetic force and the gravitational force. The electromagnetic force is not always attractive, so as it was the gravitational force. Gravitational force was always attractive, but electromagnetic force, they are sometimes attractive and sometimes repulsive. That difference comes when two same type of charges come together, that is a repulsive force. Like two electrons coming together, that will repel each other, or two protons coming together, that will repel each other. That is, the like charges repels. Plus and plus will repel each other. Minus and minus will repel each other. But when two different charges comes together, like plus and minus are coming together, then that will attract each other. But gravitational force is always attractive. Now the electromagnetic force is also a long range force like gravitational force, but this force is tremendously stronger than gravitational force in short range. The electric force between two protons, for example, is 10 to the power 36 times stronger than the gravitational force if you keep the distance between them fixed. So since the electromagnetic force is so strong, it dominates all the phenomena in the atomic and the molecular scales. Now the enormous strength of electromagnetic force is evident to us in our day-to-day life. We just don't realize it. Okay, let me give you this example. By the gravitational force that we are experiencing from the earth, we should not be able to hold this book in our hand. Okay, but the force that the book is experiencing down towards the earth, that is normalized by some other force which is known as the normal force. So this normal force is nothing but the electromagnetic force between the surface. Okay, in the surface in which the book is touching our hand, the electrons from our hand is repelling the electrons from the surface of that book. So that is the electromagnetic force's strength. We covered two forces. Now two forces are left. Those two forces are the strong nuclear force and the weak nuclear force. These two forces occur in the nuclear range. Nuclear ranges starts from 10 to the power minus 15. In the nucleus, there are protons and neutrons. But the protons are positive charged. As I said in the electromagnetic force, two positive charges, they repel each other. So according to that, protons and those neutrons, they shouldn't be able to exist in the nucleus. But this is possible only because of some attractive force. Now this attractive force cannot be gravity, because we know that electromagnetic force is really much stronger than gravity. So this attractive force needs to be something different. So there comes the need of one basic force, and that force is known as the strong magnetic and that force is known as the strong nuclear force. So just because of this strong nuclear force, a nucleus is held together, and so atoms could be formed. Now let us talk about the fourth force, that is the weak nuclear force. So weak nuclear force, that is not that weak, it is not weaker than gravity, but it is in between gravitational force and the electromagnetic force. And this weak nuclear force acts in the range of 10 to the power minus 16 meter, even smaller than the range of strong nuclear force. So when does this weak nuclear force occur? So there is a kind of decay mechanism in nuclear physics that is known as the beta decay process. In some kind of beta decay process, electron is released from the nucleus. Okay, we know that in an atom there is no electron inside the nucleus. Okay, so to release an electron from the nucleus, we need some other kind of force, and there the weak nuclear force comes to play. Okay, so these four are the basic forces of nature: the gravitational force, the electromagnetic force, the strong nuclear force, and the weak nuclear force. And each and every forces, like the muscular force or every other forces we are experiencing, is derived from these four fundamental forces. So another most important law of physics is that each and every laws in physics are valid in the universe, in each and every part of the universe. If one law is valid here and not valid in some other place, that is not a physical formula. Okay, for example, the gravity in earth is more than the gravity in moon. So you will experience 6 times less gravitational force in moon than that in earth. The law defining that gravity is same whether it is in earth or moon. So this is all about the physical world and the natural laws and the forces, types of forces. Once again, I would like to say that if you like the video, give a thumbs up and subscribe to my channel. So we will soon come up with our next video. Details of our next video will be posted in our Instagram page. So keep following that page. Okay, thank you very much.